Hi, welcome to this revision video looking at probability. Okay, this is a topic, of the Maths Genie website that will be appropriate for papers 2 and even paper 3, because it was highlighted in green on the website. So this means it will be appropriate for definitely paper 2 and possibly even paper 3. Okay, as ever guys, feel free to obviously pause the video guys, try the questions yourselves and then press play when you're ready. Okay, so we've got quite a few questions to get through today. Okay, this is question number 1 guys. The probability that a biased dice will land on a 6 is 0.3. The dice is going to be rolled 200 times. Work out an estimate for the number of times that's landed on a 6. So this is what I call expected frequency, expected value. Okay, I do the probability times by the number of possible outcomes. Okay, so times by the number of trials, sorry. Okay, so that's going to give me 60. Okay, because if I ignore the decimal point there and I do 3 times 200, that's 600, but then divide my answer by 10, I get 60. Okay. And that's worth 2 marks, okay? So to work out an estimate is always the probability times by the number of trials, or the number of trials times by the probability, of the event. This is question number 2. The probability that a sunflower will germinate, is 0.9. Alan is going to plant 50 sunflower seeds. Work out an estimate of the number of seeds that will germinate. Well, it's 50 multiplied by 0.9. Okay, 50 times 9 is 450, and then divide it by 10 is going to be 45. Okay, because there is a little trick here that says that if I multiply by a decimal, my answer is always going to be smaller. This is question number 3, guys. The probability that Frank scores a penalty is 0.86. Frank is going to take 50 penalties. Work out an estimate of the number of times Frank will score. Well, 50 multiplied by 0.86. Okay, there's a little trick here. If I multiply it by 100 and then half my answer, okay, I'm going to get 43. Okay, because if I do 0.86 times 100, I get 86, and then divide it by 2, I get 43. Okay, so that's a little trick there by multiplying by 50. Okay, you times by 100 and then you divide by 2. Okay. This is question number 4. The probability that Matt scores a penalty is 0.96. Matt is going to take 25 penalties. Work out an estimate of the number of times Matt will score. Well, it's 25 multiplied by 0.96. Okay. This one's slightly trickier. I can times it by 100 and then divide by 4. Okay, so I get 96. 96 divided by 4. Okay, let's use the bus stop method here if we're ever unsure. Half it and then half it again. We will get the answer of 48. We'll get the answer of 24. Okay. And again, you are welcome to use a calculator for this if it appears on a paper 2 or paper 3. This is question number 3, guys. In a bag, there are only red counters, blue counters, and white counters. Okay, a counter is taken at random from the bag. The table shows the probability of the counter being red and blue. Complete the table to show the probability the counter will be white. Okay. That the counter will be white. Well, probability always adds up to 1. So 0.5 plus 0.3 is 0.8. If I do 1 take away 0.8, that will give me the value for white. Okay, and the answer is 0.2. Okay, because probability must always add up to 100. Okay, it's between 0 and 100. It can never be negative, so it can never be less than 0, and it can never be bigger than 1. Okay, I can't have 101% chance of winning something. It's either 100%, okay, or anything ranging from 0 to 100%. Okay. This is question number 6, guys. Okay. Again, we've got like another probability here. So it says complete the table to show the probability that the pen will be green. Well, 0.64 plus 0.24 is 0.88. 1 take away 0.88 is 0.12. Okay, this is question number 7. A biased spinner can land on red, blue, yellow or green. The table shows the probabilities that the spinner will land on red, blue and yellow. Complete the table to show the probability that it will land on green, where you add them all up and then take away from 1. Okay, so I am going to be a bit lazy here and use my calculator. Okay. So 0.25 plus 0.34 plus 0.22, I get 0.81 when I add them together. Okay, take that away from 1 and I get 0.19. Okay, this is question number 8, guys. In a bag there are only red counters, blue counters and white counters. The number of red counters to the number of blue counters to the number of white counters is 5 to 4 to 3. Okay, a counter is taken at random, okay, from the bag. Complete the table to show the probabilities of the counters being red, blue or white. Okay, so this is looking at ratios, okay. Now, I've got 5 plus 4, which is 9, plus 3, which is 12. So, 5 out of 12 is going to be red, 4 out of 12 is going to be blue, and 3 out of 12 is going to be white. Okay? Because remember, ratio parts, okay, I don't necessarily have 12 counters in total, but that will always be the same equivalent as 5 to 4 to 3. Okay, 5 plus 4 is 9, plus the 3 is 12. Okay, so that is going to be my probability. Of course, this one can be simplified if you want, and so can this one. Okay, to 1/3 and 1/4. Okay, but again, there is no loss of marks if you don't simplify it. Okay, it's only when the question's asking you, that's when you simplify your answer. Okay. This is question number 9, guys. In a bag, there are only black counters, white counters, and red counters. A counter is taken at random from the bag. The table shows the probability of taking a black counter and a white counter. Complete the table to show the probabilities of the counter being red. Well, probability has to add up to make 1, so that's going to give me 6/10. 6/10 plus 3/10 is 9/10. Therefore, that's gonna have to be a 10th. Okay, so where I got the 6/10 was obviously that's like an equivalent fraction out of 10. Okay, I times top and bottom by 2 because I wanted to change it out of 10 because that one's out of 10 there. So 3/10 plus 6/10 is 9/10. 1 whole take away 9/10 is 1/10. 1/10. This is question number 10, sorry. A biased spinner can land on red, blue, yellow and green. The table shows the probability that the spinner will land on red and yellow. Okay, so they are given to us. Okay, blue and green are currently blank as it stands. However, it says here the probability of landing on a blue is the same as the probability of landing on a green. So if we label this as X here, label this as X, we can form an equation to solve. 0.8 plus X plus 0.26 plus X has to equal 1. So we're going to have 2X, okay, plus 0.44 if I'm not mistaken, okay, is equal to 1. Okay, so adding the probabilities together has to give me 1. Okay, so minusing 0.44 and then dividing by 2. So 1 take away 0.44 and divide that by 2. Okay, That's going to be 0.56. Divide that by 2 is going to be 0.28. So the probability of blue is 0.28 and the probability of green is 0.28. Okay, but let's double check that we have actually answered the question. It says complete the table to show the probabilities of a spinner landing on blue and green. Okay, so we have answered the question. Okay, so that's how we solve that sort of problem. This is question number 11, guys. A biased spinner can land on red, blue, yellow, and green. The table shows the probabilities that the spinner will land on red, blue, and yellow. Complete the table. Okay, so to work out green, it's one takeaway the sum of these three decimals. 0.3 plus 0.25 plus 0.15. Well, that plus that is 0.4 plus 0.3 is 0.7. So it's going to be 0.3 again. Okay, so that's part A. So Kelly is going to spin the spinner 60 times, work out an estimate for the number of times it will land on red. Well, it's going to be 60 times the probability of red, which is 0.3. Okay, so that's going to give me 18. Okay, because 60 times 3 is 180, but we're timesing it by 0.3, so it's 10 times smaller. Okay, it's going to give me that. Okay, I want to also mention one thing here. I'm going to go a bit off topic here, but it is actually quite relevant. If you see the word biased, it means that the probability of each outcome is different. It's not the same. So what do I mean by this? And a typical example is, if I flip a coin, okay, we see that it's a 50-50 chance of getting a heads or tails, okay, so it's half-half, okay, but you can get some biased coins whereby the probability of getting a heads is greater than the probability of getting tails or vice versa. So bias just means that it's not fair, okay? So this is usually like used in like events that like involve like gambling here, or like games that involve like gambling here, or like betting, okay? Because the chance of winning something or getting something out of the outcome, okay, is not always like fair for each outcome, okay? It will be biased towards one. Or for example, if someone's doing like horse racing, okay, that if you put your bets on something actually, it's essentially like a gamble, whatever. So the word bias means it's not fair. So each outcome is different, okay? Here, so red and green are the same, but blue, yellow, and green are not the same. Actually, blue, red, and yellow are not the same. Yeah, so none of these are are completely 0.3. Okay. Okay, this is question number 12. In a bag, there are only red counters, blue counters, and white counters. A counter is taken at random from the bag. The table shows a probability of getting a red counter. Okay, the probability of getting a blue counter is the same as the probability of getting a white counter. Complete the table. Well, it's one takeaway 0.2, which is 0.8, and then I'm going to divide that by 2 because they are equal outcomes. Okay, so equal probability outcomes. Okay, which is 0.4. Okay. So I'm stressing the fact, guys, that probability always must add up to 1. Okay, so the sum of the probability column or row has to add up to give me 1. Okay, if it's bigger than 1, then it's incorrect. If it's less than 0, then it's also incorrect. Okay, so I can't have a negative probability, and I can't have a probability bigger than 1. Okay, there are 18 red counters in the bag. Work out the total number of counters in the bag. Okay, so 18 is equivalent to 0.2. Now, if you look here, 0.2 to 0.5, I've times that by 2. So if I double this, okay, double 18 is 36. That's also going to be 36. Okay, because 18 is equal to the probability of 0.2. 0.4 is double 0.2, so hence why I've doubled the numbers. 36 at 36 is 72, plus the 18 is going to be 90. Okay, so that's how I work out the total number okay, of counters in a bag. Okay, this is a question that I've seen before appear in an AQA paper here and also an edXL paper. Okay, so I've seen this sort of question actually here and previous questions here appear on both the foundation and the higher tiers. So make sure that you are happy with question 12. Okay, please do obviously rewind and rewatch it if you need to. This is question number 13. A bias spinner can land on 1, 2, 3, or 4. The table shows the probabilities that the spinner will land on 2 and 4. Okay, 2 and 4. The probability that the spinner will land on 1 is twice the probability that it will land on 3. Okay, so if I label x3 as x here, and 1 is going to be 2x, because it's going to be double that. Okay, so complete the table. So if we form our equation, we're going to have 3x. Okay, so 2x plus x is 3x. 0.32 plus 0.17 is 0.49, I believe. Okay, that has to equal 1. Subtracting 0.49 on both sides and dividing by 3. Okay, I get x is equal to 0.51 divided by 3, which is 0.17. Okay, so the probability of it landing on a 3 is 0.17, okay, but we're going to be very careful for the probability of 1 because it's 2 lots of x. Therefore, that's going to be 0.34. Okay, so that's that one there. Okay, it says the next part, Johnny is going to spin the spinner 200 times. Work out an estimate for the number of times it will land on 2. So we're going to do 200. Okay, multiplied by 0.32. Now 0.32, okay, as a fraction is 32 out of 100. So I'm essentially doing 200 divided by 100, which is 2, and then doubling 32. So 2 times 32 is 64. Okay, so that's one way of doing it. Okay, and I also would like to point out actually that if you made a mistake on part A, but part B you follow through with your decimal number or your percentage number or your fraction, okay, you will still get full marks because part B, yeah, is looking at like a slightly different knowledge. But if you follow through even without the wrong decimal and get a whole number answer, okay, you should in theory still get the full 2 marks because you are following the same method. Just because the decimal is incorrect here doesn't mean that you can't get the mark there, okay? So it's something called like a follow through mark, okay? So it will still give you at least 1 mark for that, okay? But they may even give you 2 as far as I'm aware because you are still using the same technique, okay? It's just a different number instead. This is question number 14, guys. The table shows probabilities that a biased dice will land on 1, on 2, on 3, and 4, and 5, and 6. Okay, the dice is rolled 200 times. Work out an estimate for the number of times it will land on a 2 or a 4. Now, the word or here means that I'm going to have to add, probability of 2 and 4 together. So the 4 we don't know, but we can work out, okay, because probability has to add up to make 1. Okay, 0.14, so that's going to be 0.24, 0.32, okay, 0.32, 0.45, okay, plus 0.1 or 0.21, okay, is going to be 0.66, okay, so it's going to be 0.34, if I'm not mistaken, guys. Okay. So the probability, the estimate for the number of times it lands on a 2 and a 4, I do 0.2 plus 0.34, which is 0.54, and then I multiply that by 200. Okay. So hopefully you all follow me so far, okay? So the first part that I did was I worked out the probability of 4. Probability has to add up to always make 1. 0.14 plus 0.2 plus 0.08 plus 0.13 plus 0.21 gave me an answer of 0.66, okay? I took that away from 1 and I got 0.34, okay? Here I'm going to get 108, okay? So we're going to estimate to have 108 times, okay? That it will land on a 2 or a 4, okay? This is question number 15, guys. In a box, there are only red pens, blue pens, black pens, and green pens. The table shows the probability that it will land on a red or will be green. The probability that the pen will be black is 3 times the probability that it's going to be blue. Okay, so that's going to be x, and that's going to be 3x. Okay, there are 28 green pens in the box. Work out the number of black pens in the box. Okay, so there are 28. Okay, green pens. So again, forming our equation to work out the probability, I'm going to have 4x, okay, plus 0.56 has to equal 1 whole. Okay, taking away the 0.56 and then dividing by 4 gives us the value for x. Okay, so x we should know is 0.44 divided by 4, which is 0.11. Okay, so 0.11 goes there. Okay, 3 lots of that is going to be 0.33. Okay. Right, so 28 is for green, okay, and that's equal to 0.14. Now, so this is where, yeah, it is going to get a bit tricky here. So 0.42, right, that's going to have 3 times as much as this, so it's going to have 28 times 3. So what we want to do is we are going from about 0.44. Okay, so we're going from 0.14, sorry, to 0.44. So if I write it like a ratio, so if I say 0.14, right, to 28, okay, and then I've got 0.33, and I want to work out the value for that to x, okay. Now there is one of 2 ways here, okay. What I'm going to do is I'm going to do 28 times 0.33 and then divide it by 0.14, and I get the answer of 66. Okay, so there are 66 black pens in the box, okay, because there is no like easy decimal that goes from there to there, okay. But essentially what I'm doing is I'm going to work out like a scale multiple that goes from there to there actually, and then times it by that number, okay, to obviously it. Now because obviously that decimal is bigger, we know that my answer has to be bigger than the 28, okay. So that's how I worked it out, guys, okay. This is question number 16, okay, last question for today's video. In a bag there are only red counters, blue counters, and green counters, and yellow counters. Okay, a counter is taken at random. The table shows the probabilities that the counter will be green or will be yellow. The probability that the counter will be red, okay, is twice the probability that it will be blue, so that's going to be x. That's going to be 22x, sorry. There are 21 green bags. Okay, counters in the bag. Work out the number of red ones. Okay, so let's form our equation first. We're going to have 3x plus 0.55. Okay, when you add those is equal to 1. Okay, solving this linear equation, so taking away 0.55 from both sides and then dividing by 3, okay, I get that x is equal to 0.45 divided by 3, which is 0.15. So 0.15 there, and then red is going to be 0.3. Because it's twice that, okay, 0.30. Now it's saying that there are 21 green counters in the bag. Okay. So to go from 0.35 to 0.3, okay, I'm going to be dividing all times it by something, okay, times by. So if I do 0.35 divided by 0.3, okay, I get 1.16 reoccurring, okay, and if I do 21 divided by, okay, I get the answer of 18. So there are going to be 18. Because if I write it like this, guys, so let's write it in the ratio 21 to 0.35, okay? So we've got that. Now we've got the probability here as 0.3. Okay, so I want to work out this missing part. Now the way this works in a ratio is I do 21 times 0.3, so I times diagonally and then divide by the vertical. So 21, okay, times 0.3, okay, divide that by 0.35. Okay, so let's just double check this, okay. So 21, guys, times 0.3. We're going to divide that by 0.35, and I get the answer to be 18, okay. I got the answer actually like a different way, and I also got 18, okay. So that's how I worked out that, okay. So I did 21, okay, times 0.3, okay, and then I divided that, okay, by 0.35. Okay, so I worked that out actually. I got 6.3, and then I divided it by 0.35, and I got the answer of 18. Okay, so there are 18 red counters in the bag, okay? And I can use that ratio to work out any other ones, okay, if you're interested, okay? But essentially what I'm doing here is that cross multiply, so it's that times that, and then divide it going that way, okay? And it was similar here. Here I did 28 times 0.33, so I times those, and then I divided it by 0.14, okay? So I times diagonal, and then I divided it by the remaining ratio part, okay, to work out the missing ratio part there, okay, because it's always looking at equivalent ratios here. Okay, right guys, that's the end of today's video, okay, so thank you so much actually for watching the video, thank you so much for making it to the end. If you did find this useful, please press like, okay, so hit that like button so YouTube algorithm knows that my videos are good, okay, and helpful and useful. Okay, subscribe to my channel if you're new. And lastly, click that bell icon to turn on post notifications so you guys don't miss out on further and future videos for this channel. Okay, but that's it for me today, guys. Thanks for watching, take care, and I'll see you for the next one. Bye for now.